Now there's one more type of trigonometric equation that I wanted to cover today, and these look intimidating, but there's really only one extra trick that you need to know. There's one cultural thing that you need to know as well, which is what does sine squared x mean? When we write that, we always mean first take the sine of that x and then square. We write it that way so that we don't get confused with sine of x squared, right? Where you're supposed to square the x and then apply the sine function. So once you know that, what are you supposed to do with this equation? Well, you notice that this is sine x times sine x, and this is sine x. That means that these two expressions here, these two terms, have a factor in common. We're going to factor out that sine x and then write the leftovers inside a set of parentheses. So once this equation is completely factored out, you split because it equals 0. You can write sine x equals 0 or sine x minus 1 equals 0. Solutions of both of these equations are going to count as perfectly good solutions to the overall equation. Now, if this looks fancy to you, remember that this is just like what you already do with polynomials. If you saw this cubic set equal to 0 and you needed to solve it, what would you do? Well, most of us would factor this. You would see that all three terms have an x in common. What's left over is a quadratic that factors perfectly well. And I bet you're doing some mental steps ahead of time here, and you can see that the solutions are 0, 1, and 3, right? Well, formally though, what's going on? What's going on is because you have three terms, three expressions that are multiplied together and equal 0, when you have a product of three different numbers and it's equal to 0, at least one of them has to be 0, and it can be any one of them that's 0, maybe two, who cares? So what you get to do is you get to split this product of three things into three separate equations that all equal 0. You have to have equal 0 on the right though, or it's no good. So back to the trigonometric equation. Once you make this into a product of two different expressions, you get to split and set them both equal to 0 and solve that. And these are both well within our wheelhouse. Now sine x equals 0, well, we know that the sine function gives us 0 whenever the terminal edge points exactly to the right or to the left. That corresponds to 0 and pi and all the coterminal angles for that. And sine x gives us positive 1 at only one spot, when the angle is pointing straight up, when the terminal edge points straight up. So these are the three locations that will give us solutions to the overall equation. And so what I'm going to do is write them down in three different sets. I have 0 plus 2 pi k, pi over 2 plus 2 pi k, or pi plus 2 pi k, where k is any integer. That's exactly what I'm going to write, and I'm going to be done with this problem. So remember, if you see a big old trigonometric equation like that, maybe you can try factoring to solve, especially if you see equals 0.